Hey guys, I want to make sure that you kind of get everything that we did on this assignment, so I'm actually going to run through every single problem right now. So, find the absolute value of negative 7. That would just be 7. And in case you're like, okay, how in the heck did he figure that out? The idea, and some of this you might want to skip ahead through, the idea is that if you take a number line and you were to write all the numbers, I'm going to do a little bit of skip counting here. 5, oh no, we did 6, 7. I really am never trying to do this on purpose. Negative 6, negative 7. Okay, great. So where is, what number are we working with? We're working with negative 7, so there it is. The question basically is, how far is that number? What is its absolute value? What is its distance from 0? And I think that you know that the answer is it's 7 steps away from 0. So that's why the absolute value of negative 7 is 7. Okay. The absolute value of negative 3.2 is just 3.2. The absolute value of negative 13 fourths is 13 fourths. And the absolute value of 0 is 0. And just a reminder, in case you're not hearing me or you want a visual, I'm reading this. I read this like absolute value of 0. Like that's the words for that right there. Okay. Complete the statement using less than, greater than, or equal to. So what we need to do is first simplify this to be 4. 4 is going to be greater than 12 over 5. And if you're not sure how I did that, 12 over 5, well, I mean, you could do the division and you would get 2 something. And if you're like, wait, how did he get 2 something? And why just 2 something instead of like 2.4 or whatever it really is? Well, I don't really need to do all of the math in order to figure this out, because 5 times 2 is 10, and so this is 12, which is pretty close to 10. So again, that's why this is 2 something, and 4 is bigger than 2 something, right? Okay, 5.8 and the absolute value of negative 7. Well, this is 7, so this is going to be less than. So here's my answer here. Here's my answer here. 5.8. By the way, I forget that I like to point. I'm pointing with my pen, but you can't see me pointing because it's a video. 5.8 is less than 7. Okay. Then we have the absolute value of 8. That's pretty easy. That's 8. And 8 is definitely greater than 5. While playing a game, you move back 5 spaces. But you move back 5 spaces, and with your roll of the number, your friend moves forward 3 spaces. Write each amount as an integer. You move back 5 spaces. Your friend moves forward 3 spaces. That's it. Order the values from least to greatest. Okay, well, first thing I'm going to do is say that that's 5 and that's 4 because, well, I mean, they are, right? And then I technically want to, convert and think, okay, which one is the smallest? That guy is the smallest, so we're going to go negative 2.1. And then negative 7/12. And if you're like, wait, how do I know that this one is bigger? It's closer to 0. If we were to go back to our number line up here, negative 2.1 would be here-ish. Negative 2.1's there. And then negative 7/12, that's not even negative 1. So it would be somewhere like here-ish, right? And in fact, I'm obviously using this number line right here. You could be using a number line to do this if you felt the need. 4, 5, and then 8. I mean, I think these 3 were pretty self-explanatory, but here are the answers here. Next, we got this one. Again, I think we should simplify first. The absolute value of 2 is 2. The absolute value of 4.3 is 4.3. The absolute value of 3/17 is 3/17. Hooray. So now just least to greatest. This one's pretty straightforward. 0, 2, oops, I said it's straightforward and then screwed up. 0, 3/17, because that's not even one whole. How would it be one whole if it was 17/17? That's one whole using 17ths. And so 0, 3/17, 2, 4.3, and 6. Your friend compares two rational numbers. Okay, what was a rational number again? Well, those are rational numbers. These are rational numbers. I guess one thing to clarify is when we explained this, a rational number is in this form where b cannot equal 0, right? So if you're looking at this going, oh, wait, that says 5. Yeah, 5 over 1, which could be simplified to just 5. That is a rational number, but we kind of think of these as rational numbers. So it's like if this is the bucket that contains integers, this is the bucket that contains rational numbers. So integers, rational numbers. Notice that the bucket of integers is inside of the rational bucket. Isn't that fun? Okay. So is your friend right in making this comparison? Well, let's see. This is really 5/6. So is 3/4 less than 5/6? Well, I think of these in terms of like this is 0.75. 3/4 is 3/4 or 25 cents 3 times. And then 5/6. Well, if it helps you, then I do division. And I go, okay, 6 times 8 is 48. So what we just found out is that 5/6 is 0.8 something. And so check it out. That is true. So if you look at like my answers, I just wrote yep, but here's all my explanation, right? Okay, cool. Sliding over here, the absolute value of -5 is 5. The absolute value of so hang on. We need to simplify the absolute value of 5 first. So I explained in at least 1 hour that this negative is on the outside. So the outside happens after we take the absolute value of 5. So here's what we get. We would have that 5, this 5, I guess this 5, because it's this, is equal to -5, and that is not true, not true. All I wrote on the answers was nope, but here is again my explanation. Okay. The table shows temperatures in several towns on a day in winter. Which town has the coldest temperature? So basically what they're doing is they're just saying, hey, like, what if we had a number line with all of these temperatures, zeros here in the middle, let's say this is +10, -10. Well, then town A is way over here. B, let's see, E, F, and then C is way over here. And that's about it. Did I leave anything out? A, B, C, where's D? D would be there. And if you're like, how is he doing this? He doesn't have any other numbers on here. I'm just kind of being general, right? Because if this is -10, then sure, -5 somewhere in the middle of that, right? And even right here, 5 is like there. And if you're thinking, well, C is not 5, you're right. But again, it's on the positive side. So that's kind of why I said that. So this is what we're looking at. That's what we're comparing. But really, that's the information. So let's see, which town has the coldest temperature? A. A has the coldest temperature. Which town has the warmest temperature? C. And if you're like, why is he writing B? Because B is that answer. A is that answer. And C, which town has the temperature that is closest to 0? That would be D. And if you're like, how do we know that's the closest? Again, the absolute value of these is the distance from 0. That's 2 from 0. 5 from 0, 4 from 0, 3, 8, 10. This guy is clearly the closest. Use a number line, graph and label the following points on a number line. So I'm going to do this guy down here. So here is my number line. Here's how I do number lines. I put a 0, and then I look at my numbers, and I make it easy on myself. I look at the smallest number, which is -8, and I put it on the far left. I look at my biggest number, which is 4, and I put it on the right, because I don't want to have to set things up. I know that may seem a little lazy to you, but there we go. And then there's -5, which is, let's say that's right there, and then 1, which is right there, 1. Okay, so here's what we're going to do now. We're going to take what those letters are and put them on the number line, L, A, T, and E. So what word does that spell? It spells late. Now, there's a little bit of a shift in thinking for this one in that it says, okay, now graph the absolute value of those things. Well, we're going to need technically a different number line now, because the absolute value of -8 is 8. And the absolute value of -5 is 5. 4 is still there. 1 is still there. Notice there's actually nothing over here because the absolute value technically returns positive numbers, right? So, okay, 8 was L, 4 was E, 1 was T, and 5 was A. So, teal. So the answers were late and teal. All right, we just got a couple more to do here. Write an integer whose absolute value is greater than itself. Write an integer. Okay, let's break this down. Write an integer. Here's my biggest, advice. Pick a number. When you're doing problems like this, where they're asking you to write something, same thing with over here, they're saying, hey, determine. They're wanting you to kind of come up with something, you to kind of do some reasoning. So we're going to pick a number here. An integer, well, okay, what's an integer? 2 is an integer. -2 is an integer. 0 is an integer. 50, -50. You get the idea. But here's what they're asking us to do now. They're saying, okay, well, write an integer whose absolute value, so what's the absolute value of 2? It's 2. What's the absolute value of -2? 2. So whose absolute value, which is these guys, is greater than the original integer. So if you're kind of following along, here's what we just found out. 2 is not greater than 2, but 2 is greater than -2. So your answer here is any negative integer. That is your answer for number 15. Slide over here on the back to do a little bit of review. We're going to write ratios. Deers to bears. There's 1, 2, 3, 4, 5, 6 deer. So right away the ratio is 6 to, and how many bears? There are 1, 2, 3, 4. 6 to 4. You could write it like that. You could write it like this. You could say 6 to 4. You could say 6 to 4. You could also reduce it to be 3 over 2. I really don't care. That is the answer for number 1. And then for bears to deers, you literally just switch it around, okay? Bears to animals. Okay, well, there were 4 bears, and there are, 10 total animals. So 4 to 10 like that, and we could switch it to also be 2 to 5 if we were to reduce it. And then lastly is animals to deer. There are 10 animals. There are 6 deer. Again, we could reduce it, and it could be 5 to 3. Also, it occurs to me that number 4 is not technically on yours. Neither is number 8. So if you're like, wait, I didn't get that, don't worry. I forgot. I just chopped off some of the problems just to make it a little bit shorter. You're welcome. Find the greatest common factor. That's what this stands for. Greatest, let me come over here. Greatest common factor. And what is that? Well, a factor is like this. 8 is really 2 times 4. But you know what? 4 can be broken up into 2 times 2, so check this out. 8 is really equal to 2 times 2 times 2. Wow, that's fun. The greatest common factor of 20, well, there's 2 times 10, there's 2 times 5. So 20 is really 2 times 2 times 5, yeah? And then here's all you do. You circle the amount, or the factors that they have in common. They have 2 and 2 in common. 2 times 2 is 4. The answer is 4. The answer is 4. Why is it 4? Because of 2 and 2. All right, check it out. 6. And some of these you're going to just start to see. Like, for example, I look at this and I'm like, that's 6 times 2. That's 6 times 5. And then I'm going to stop there because they both have a 6 in common. That is their greatest common factor, so the answer is 6. And if you're like, oh, but I kept going. Okay, well, then you would get 2 times 3 times 2 for this one, for 6. No, you wouldn't. Oh, for 12, I mean. And for 30, you would get 2 times 3 times 5. Well, okay, 2 times 3 is 6. 2 times 3 is 6. There you go. And then same thing here. This is a prime number, so it's 7 times 1. And this is 7 times 4. Oh, look, the answer is 7. All right, down here are the problems that you might be thinking, oh, dude, I need some major help. Determine whether n is greater than or equal to 0. So think about this for a second. These are positive numbers. And over here, n is less than or equal to 0. These are negative numbers, okay? So just like I said over here, I want you to pick a number. So we're looking at this. Why don't we pick an easy number to work with? 5. That would fall into the positive number category. In fact, why don't we write it as blue? 5. So what I'm going to do is I'm going to plug it in, okay? And here's what I'm going to do so that you can kind of follow me plugging in. If it's written in black, I'm going to rewrite it in black. So plus absolute value of negative absolute value equals 2. And now here's where the 5 goes. 5 and 5 times 5. So the absolute value of negative 5. All right, so if you're like, oh, well, now what do? You simplify. PEMDAS is how we simplify. So the absolute value of negative 5 is 5. Plus this 5 right here. I'm going to write it in blue because it didn't change. And then over here on the right, 2 times 5 is 10. Check this out. Does 5 plus 5 equal 10? It sure does. So right away, we know that this one is going to be positive numbers, or you could say it is n is greater than or equal to 0. That is the answer for number 48, okay? And then for 49, let's just go ahead and pick a negative number. How about like negative 5? Notice I'm going to like certain numbers. Some numbers that are nice to pick are, check this out. No. I don't like to pick those because I don't think they work really well. So why not 0 and 1? Because sometimes when you plug them in, they don't exactly work. Like for example, over here, if you plugged in 0, you would get 0 plus 0 equals 0, and that would work. And over here, it would work also. So are they both 0? No, that's not how it works. So anyway, plugging in negative 5, so we have plus the negative, let's get the red going, negative 5, negative 5. So let's check this out. We got the absolute, well, hang on. So inside of this, we have negative 5, and that's 5. So what's the absolute value of 5? It's 5. So hang on, let me kind of bring down this negative 5 each time and the equals 0 each time because those didn't change. And then check this out. What's about to happen is negative 5 plus 5, is it 0? It sure is. So the idea is that negative numbers or n is less than or equal to 0 is the answer for this one. Let me know if you got any questions.